I'm here today to talk to you about the Joint Centre. But before I do, I wanted to thank you very much for inviting me. It's such a pleasure to be here. Right, so in today's talk, so I'm going to split my talk into three brief sessions. First of all, why me and why us? Secondly, why now? And then thirdly, why the Joint Centre? So first of all, why me? So I thought I should probably start with saying a little bit about myself, because we've not met, so this is my introduction. So hello everyone, I'm Kirstine. In my head, this is who I am. I'm still 8 years old in my head, and I still have that lovely pink cape that I thought made me look like Wonder Woman, which I look back on now and maybe it's a questionable style choice. And I have a basin haircut, which I think was done by my mother with the big scissors that none of us were allowed to touch. But that's who I am in my head. So who am I now? Well, I am now mother to this grumpy snowman. My son is nearly 18 now. He doesn't fit that jacket anymore, but I still have it. I'm thinking it might become a family heirloom, so that's where we're going. So what do I care about? For me, it has always been science, and I think that's probably true for many of you in the room. For me, science is like magic, but it's even better because it's real. And I believe that science, the power of science is realized through innovation, and that innovation can be catalyzed by multidisciplinarity and diversity, which is one of the reasons I'm so delighted to be here today. So what's my job at the moment? So I am Principal Fellow for Data Science at the UK's Met Office, and I am Co-Director for the Joint Centre for Excellence in Environmental Intelligence. This picture is the building, the Met Office building in Exeter in the UK, where I work. So a little bit about the Met Office. So the Met Office is the UK's national Met Service, but it does much, much more than that. Its vision is to be recognised as global leaders in weather and climate science and services in a changing world. It was set up in 1854 by this rather dashing chap at the bottom right, and this is Vice Admiral Fitzroy. I like to think he was a big fan of innovation too, because he was actually the captain of HMS Beagle that took Charles Darwin around the world, so a bit ahead of his time. It predates Vice Admiral Fitzroy, obviously, but the data science goal at the Met Office is now to harness the power of data science to push forward the frontiers of weather and climate science and services. So I said that we do much more than weather forecasting. This is a slightly old slide, but it attempts to show some of the different activities that happen at the Met Office. So obviously we produce the weather forecast, but much more than that, we do forecast for multi-hazards. So for example, we do forecasts of where volcanic ash might go. This is really important for determining flight paths for aircraft. We provide climate information for the United Nations Intergovernmental Panel on Climate Change, so to inform the negotiations on climate change, mitigation and adaptation. Bottom right, we also do a lot of work for international aid, and this spans climate, mitigation and adaptation, as I mentioned, but also emergency response on the weather timescales. So the breadth of what the Met Office does is much, much broader than you might think. It's not just the weather forecast. So how do we do this? We have a fairly standard production chain, which runs from observations, simulation, analysis, through to products. So on the observation side, I always forget this figure, and it does change quite a lot. We have 250 billion observations that come into the Met Office every day. So that's quite a lot of data coming our way. We then run those observations. We do some data assimilation first, but then it goes into simulation, so looking at the unified model, so the code for producing the weather and climate forecast. The simulation code is currently 3 million lines of code. That is primarily Fortran, but we have some auxiliary and helper code, which is in Python. So big message from the first 2 blocks is definitely big data, big models. The next stage is analysis. So this is where our forecasters get involved. They have a look at the output from the model, and they produce products which help people stay safe and thrive. So that's the products on the right-hand side. So machine learning is used across the whole value chain, across the whole production chain, sorry. And I put some examples on this slide, and I probably won't have time to talk about all of them, but I'll give it my best shot. Right, so starting on the left for observations. Here we use, this is a photo of somebody putting in an ocean probe, which travels through the ocean collecting data on temperature. That's really important because when we have that data, you can look at profiles of how the temperature of the ocean changes over time, and that's really important for things like climate change, so assessing how temperature has changed. 50% of ocean probes lack metadata, which means that it's very challenging to do bias correction. So we use machine learning to classify ocean probes. This enables us to do the bias correction, which enables us to ensure that we have a robust record of how the ocean's temperature is changing. Next one along, this rather dashing fellow is Socrates. And this is to remind me that within the unified model, so the large simulation model that we use machine learning for specific parameterizations in the code-specific activities, and we use machine learning to provide emulations for codes. The Socrates one is actually the radiation scheme, and we use a machine learning emulator. Big advantage of emulation is it's faster, more accurate, and in some cases cheaper to run, which means less CO2 because you're using less compute power. And although I put Socrates down there, so the radiation scheme, we're starting to use emulation for lots of other schemes within the numerical weather prediction. Next one along is the lightning bolt. And this is to remind me that we use machine learning to identify sudden ionospheric disturbances in the lightning detection scheme, which can signal coronal mass ejections, which are fireballs. So that's quite important. So we use machine learning for that. Moving swiftly on to the last one on the right, we have some work with the National Met Service in South Africa using machine learning to develop future wave climatologies, and that's particularly important in South Africa because they have a lot of vulnerable coastal infrastructure. Not only that, but in the region there's a tendency for what are called monster waves. So you need to know what the future climatology is going to be, what's the future wave situation going to be in the future, so you can make decisions about resilience and making sure that you're prepared for the future. So now I'm going to move on to why now. Okay, nobody can have failed to notice that artificial intelligence is rising up the agenda and our capability is going through the roof. Hence, we have conferences like this. Hence, almost every day when I turn on the radio and listen to the news, there's a new article about artificial intelligence and novel applications for how it's being used. There is a revolution in artificial intelligence underway, and this has been called the Fourth Industrial Revolution. And this revolution has been brought about by 3 factors. Firstly, we now have unprecedented volumes of data. I've already mentioned the observational data that we have for weather forecasting. Imagine this, thinking about all the different domains. There is just so much data around. We also have increasing availability of powerful computing capacity, and much of that is in the cloud. So we are ubiquitizing and democratizing cloud access. And there are expert scientists, such as many of you, equipped with the data science and tools needed to use the supercomputers to extract meaning and value from the volume of data that's available. Critically, this revolution is taking place against a backdrop of climate change. So I put 3 pictures down the side. Now, these pictures are all from 2021, I think. The top one is the Siberian heat waves, where there were wildfires. Incidents like that are now 600 times more likely due to climate change. The middle image is from the same year. These are the European floods, again, more likely under climate change. And then at the bottom, I think I've put the North American heat wave. This is when temperatures reached 49.6 in Canada, so very, very hot. People like me from England and my son with his red hair are going to melt in 49.6. Okay, so the need for action on climate change is urgent, but it's not too late. And our need for prediction and impacts has arguably never been greater. And coincidentally, and fortuitously, there is now a deluge of environmental data, so rich that only automated systems can fully exploit them. So in short, the 4th industrial revolution is extremely well-timed, and it falls to us to use the tools and techniques that we have in data science to join the fight against climate change. So last year in the Met Office, we put together a new strategy or framework called the Data Science Framework, the goal of which was to harness the power of data science to push the frontiers of weather and climate science and services forward. And within that data science framework, and I put a link on the previous slide if everyone wants to have a look at it, we have 3 main pillars. The first is identifying our 4 priority capabilities. So these are the areas that the UK Met Office is going to strive to lead in and to develop expertise that can be used not only within the Met Office, but in partnership with other organisations. Secondly, I don't know why it's come out as number 1 as well. They're not all, it's 3, I promise. The second one, people. We are committed to creating an enabling environment that attracts, trains, and develops a skilled and critically a diverse workforce. And thirdly, partners. Data science is moving so quickly that no organisation can stay at the front all the time. I think it's absolutely imperative that we form the necessary partnerships to make the most of this opportunity. And I put the star on that because this pillar in the data science framework is the reason that we set up the Joint Centre for Excellence in Environmental Intelligence. So that brings me to the third part. Why the Joint Centre? Oh, that slide doesn't look quite how I expected. No matter, I can do it. So, the Joint Centre is was initially a partnership with the University of Exeter, which is our local university and one of the UK's strongest universities for environmental intelligence. And we set this up during 2021, so during COVID. It was an exciting time setting up the new centre. So what is environmental intelligence? So environmental intelligence, and I'll point you to the box at the right-hand side, top right. This is taking environmental data plus artificial intelligence to have environmental intelligence. So environmental intelligence exploits the explosion in environmental data and rapid advances in artificial intelligence to create solutions to the challenges facing society today. As I mentioned, the Joint Centre was initially set up with the University of Exeter, but we're now operating as a central hub for a network of partners, both within the UK and internationally. We have Our structure is 3 work streams. There's research, development, and application, which looks at how you might apply environmental intelligence to address some of the challenges facing society. We have infrastructure, data engineering, research, and we have capacity building and skills development. So, for example, under that last one, this September, we will be launching a master's course in environmental intelligence. So together, those 3 work streams enable us to provide insight to inform decision-making, improve risk management, and the technological innovation that's needed to support a sustainable interaction with the natural environment. We have a fairly broad area of research, but 2 areas that we've been looking at recently are climate change and clean air. So I thought I'd give you some example projects. So top left, climate change and food security. We have been looking at how to use AI to integrate crop and disease models with climate data, and also integrating remote sensing and predictions. This is really important because agricultural productivity is an indicator of food shortages and food security. The next one I've highlighted here, bridging spatial scales. Here, again, we're using AI and machine learning to blend satellite and surface data. So it's quite similar to the first one in that one of the big challenges is how do you blend different data sources, different data types, different models, and different model types together. We're doing that both in the food security project, but also in the bridging spatial scales. And the third project I've highlighted is CLIMAR. So CLIMAR is a bit of a flagship project for the Joint Centre. It stands for Climate Change Impacts, Adaptation and Resilience. And in CLIMAR, we are quantifying and visualising the risks associated with climate change. To do that, we draw on the Intergovernmental Panel for Climate Change's model for risk, which breaks risk into vulnerability, exposure, and hazard, where hazard is the weather or climate aspect, and vulnerability and exposure can change depending on the application. So far we have applied CLIMAR to look at urban heat, and in particular there's a city in the UK where we've been working with the council to try and quantify and then visualise their exposure to the urban heat island effect moving forward. We've also used CLIMAR to look at risks of flooding and in particular risks facing critical national infrastructure. And we're now looking at how to apply CLIMAR to look at energy security, because obviously there are weather and climate dimensions to both energy consumption and energy production. I'm afraid I can't show you this at the moment, but there's a YouTube link here if you'd like to have a look, which has a video which shows a bit more detail about CLIMAR. So, in conclusion, the Joint Centre has been the perfect mechanism for me to bring together my interests in innovation and multidisciplinary working, like so many talks that you've had today and that you're going to have this afternoon, actually. The big theme is multidisciplinarity. So the tools and techniques of data science require other domain specialists to work together in these multidisciplinary teams to realise the impact and the value. So environmental intelligence is really critical when tackling many of the challenges facing society. And as a way of illustrating that, I've put on the Sustainable Development Goals on the right-hand side of this slide. So not only is climate change, environmental data obviously relevant to SDG 13, which is about climate action, but I think it feeds in as part of a multidisciplinary approach to many of the other sustainable development goals. So the ones that I would probably highlight would be number 1, poverty, number 2, hunger, number 3, good health and well-being, Number 6, clean water and sanitation. Number 7, affordable and clean energy. The list goes on. In fact, it's probably easier to identify which SDG doesn't have an environmental component. I think that data science can provide the tools that we need, that environmental science can provide the data and essentially the domain expertise we need to apply those tools, and that a multidisciplinary approach, which you're hearing a lot about today, but a multidisciplinary approach is essential and will spark the innovation that we need. Thank you.
Thank you for such an interesting talk. It's like dealing with enormous amount of departments. So I would open for questions if anyone wants to from the audience. Oh yeah, there we have one already, yes. Otherwise I also have some questions, but...
Thank you for the interesting talk. I didn't quite understand, does the Met Office work with foreign countries? Like, do you try to influence, for example, air quality to get better in some way? Or how do you cooperate on an international level? Because you said something about South Africa, so I'm wondering.
Yep. Gosh, that's quite a big question. So the Met Office, the UK Met Office is part of a global network of national Met services. So there's 196 countries who are part of the World Meteorological Organization. So this provides the way for us all to work together, because weather doesn't respect national boundaries. So it's really critical that we work together and that we share data and models as much as possible, so that we're all working with the same sort of information. So that's the first way we work internationally. Secondly, we also provide climate information for the UN's Intergovernmental Panel on Climate Change, IPCC, and that is to inform their deliberations and the negotiations of climate targets for different countries. That data is global because, like I say, climate's a global issue. And then the third way I should probably highlight, and I used to work in this team actually, so the international development team. Here we work with other national Met services primarily to look at how we can tackle weather, like exposure to extreme weather, how we can preempt it, get ready, and manage during the event, and then recover afterwards. But also on the climate timescales, thinking about local adaptation and mitigation. So yes, we do at the UK Met Office work internationally, and there's, like I've highlighted, 3 areas. There are more areas, but yes, we do quite a lot.
Thank you. Very interesting.
So, okay, we take one question, and then we have one question from Slido, and then, yeah, I think we have time for some questions.
Yes, thank you very much for this exciting presentation. Just building on the previous question, I'm wondering, with all this collective genius of all these experts and this multidisciplinary approach that you mentioned that is key, what do you think is the key on the how you approach solving problems together to actually be effective? What is key, but also what could stand in our way?
Oh, that is such a good question. So how do multidisciplinary teams work together? I wish I had the answer to that. I can probably draw on my experience, but I don't have the answer to that. If I did, life would be a lot easier. What's my experience? Multidisciplinary teams. Right, I think we're constantly, through the Joint Centre, but also through my work with the Met Office, we're trying to set up this multidisciplinary team. So, for example, when CLIMAR is used for a different sector that maybe we don't have much expertise or much experience of working with, the first thing to do is to set up the multidisciplinary team. What are some of the hurdles? To start with, the first hurdle is always going to be language. it's actually really difficult for me to talk without using acronyms. I kind of only realise it when I come and do a conference talk, and I'm like, you can't just use IPCC, you're going to have to expand the whole acronym. And it's not just me, everybody speaks in acronyms, and we all speak in jargon. And I think that one of the big barriers for multidisciplinary teams is ensuring that you're using the same language in the same way. So recently I went to a meeting where we were talking about developing a digital twin for the environment. And I was talking to a technology team, and I realized quite quickly that they were talking about quantifying uncertainty in a completely different way to what I meant. And there were, that's just an example, but there were lots of other terms when it was a bit like, okay, I feel like the first thing we need to do is just check that we're talking about the same thing and that we're using the same language. To help with that, I think post-COVID, there's no substitute for actually seeing people and talking to them, because sometimes it's only the informal chats that you have which make you, number one, realise that you weren't really talking about the same thing, and number two, that's where the spark of innovation happens, because sometimes it's serendipitous, you just don't know what's going to trigger it. So that was a slightly long-winded answer,
Thank you very much.
Since I started by saying I don't know. But
Thank you. I think that summarizes quite a bit. We do have a question, interesting one. I'm wondering if you can give examples of policy decisions from the UK that have come out of your data analysis.
Another really good taxing question. We, in the UK, our owning department is, it's just been renamed actually, so I think it's now called the Department for Science, Innovation and Technology. We used to be called, actually I'm not going to tell you what it used to be called because it's another acronym. We provide, at the UK Met Office, we have a large programme called the Hadley Centre Climate Programme, which looks at climate change, observations in the past and predictions of how it's going to change in the future. And the predictions in the future aren't just of meteorological variables, they're impacts. So how might sea level rise? How might that impact certain areas? We provide that information for UK government, and they take that information to the negotiations at the Intergovernmental Panel on Climate Change, which every 3 years meets to think about what are the new targets. So you will recall that Conference of the Parties in Paris, very big, important negotiation. We don't provide all the information, but we provide a very significant part of the climate information to inform some of those negotiations. Okay.
That answers it, thank you. And then there's another question, Slido, which is quite interesting. Like, are the efforts of the Joint Centre focused on slowing down climate change, or rather finding ways to adapt? And which is most important in your opinion?
Not enjoying the questions. Okay, right. So we'll start with the last bit, because that's slightly harder. Adaptation and mitigation. What do I think the balance needs to be? I'm really sorry, but I think these are two sides of the same coin. I think that we need adaptation because we need to be ready for the change that we're already committed to. But we also need mitigation because we need to avoid future change. So I'm really sorry, but we need to do both. Focus of the Joint Centre. Is the focus of the Joint Centre adaptation or mitigation? Well, it's not like we have chosen to focus on adaptation or mitigation, but looking at the current portfolio of projects, I'd say it's slightly more tilted towards adaptation at the moment. So like the CLIMAR projects looking at resilience and risk management of climate change in the future. So that's more about adaptation. But sometimes knowing the risks of climate change in the future can spur action for mitigation because they just seem like unacceptable risks. So although I think our portfolio at the moment looks slightly skewed towards adaptation, I hope that some of it is prompting thoughts about mitigation as well.
Thank you. And since we have a couple of minutes left, any questions from the audience, like one or two?
These questions are so tough. If I'd have known there was going to be extra time, I'd have spoken slower or done more slides. Jeez, anyone got an easier question?
I think I have
Anybody
an
want to
easier
know where I
question.
bought the coat?
You were talking about C probes and that they lacked the metadata. Hopefully an easier question. What metadata would you normally expect to come in with? Is it just location, or do you also need brand, etc., so that you can balance the data coming in from those?
Oh, this is a great question. I think you've almost answered your own question. I love that one. Yes, we do need information on the make of the probe. We need to know where it was dispensed, when it was dispensed, how it was dispensed. There's everything that you've mentioned is all essential for correcting the bias in the temperature probe. So, yes, sorry I'm not being more specific, but all of that data, all of the missing metadata is needed.
No, that's great. Thanks very much.
Okay, I think I have one more, hopefully easy question.
Okay.
Who are your top industry and academic collaborators?
Oh, I don't want to offend anybody. Oh, God. Right, so within the Joint Centre, that's relatively easy. Our top academic collaborator is going to be the University of Exeter, who are pioneering environmental intelligence and set up the centre with us. So that's a nice, easy question. We're starting to work with lots of other academic partners. So Imperial College. I'm not going to mention them, because if I forget to mention someone, that'd be really bad. So I'm just going to go for Exeter to begin with. Who are the industry partners? It varies over time for the Joint Centre. It kind of depends on the project that we're working on. Okay.
Yeah, thank you. So, one or two last questions from the audience.
No more! I don't mind. Really, we can do another question if you really, really want.
Okay, otherwise, if you have any last comments and so on for everyone here, how maybe they could help in...
No, but I'm going to... one of the challenges I would put out to everybody here is I've said a lot about multidisciplinary teams, and this being one of the ways that we will spark the innovation that society needs. I think the challenge for everyone here is to think about networking with people who are outside your domain, because they're going to have a different perspective, a different set of challenges, and the stuff that they might be finding difficult that you don't find difficult, and conversely, the stuff that you might be finding difficult that they're not finding difficult. So in your coffee breaks and in the lunch break, try and find someone who works in a different domain to you, because who knows what might happen. You might have that spark of innovation that leads to something amazing.
Thank you so much. Thank you for your insight. Here's a little goodie bag.
Thank you very much.
Thank you.